Imagine London in 1860. Not the London you might see in photographs, but the reality on the ground. The streets are chaos. Complete, utter chaos. There are so many people that you can barely move. Horses everywhere. They're pulling carriages, delivery wagons, omnibuses. The smell would have been overwhelming. Animal dung, human sweat, cooking fires, industrial smoke all mixing together. Carriages are jammed against each other. Traffic moves at a crawl, sometimes stopping entirely for hours. People are shoulder to shoulder on the pavements, dodging vehicles, shouting to each other to get out of the way. The city is absolutely exploding with population. Between 1800 and 1860, London's population more than doubled. It went from about 1 million people to over 2.5 million. Nobody had really anticipated this. The infrastructure that worked for 1 million people simply couldn't handle 2.5 million. The roads were designed for a different era, a different scale, and there was no obvious solution. You can't just build more streets through the centre of London. The city is already completely built up. Where would these new roads even go? This wasn't just an inconvenience. It was becoming a genuine crisis that was starting to affect commerce, industry, and daily life. Business owners were frustrated. Workers couldn't get to their jobs efficiently. People were late to appointments. The entire flow of the city was constrained by the simple fact that there was no efficient way to move large numbers of people quickly. Engineers, politicians, businessmen, they all looked at this gridlock and realised something had to change fundamentally. But what? How do you solve a problem this massive? Most people didn't have an answer, but a few visionaries were thinking differently. Enter John Fowler. He was a Scottish engineer with an unusual background. He'd worked on railway projects across Britain. He understood how to move people and goods efficiently. He'd seen what trains could do, but trains ran on the surface, and London's surface was already maxed out. So Fowler had a radical idea. What if, instead of building railways on top of the ground, you dug down into it? What if you created a railway that ran entirely beneath the streets of London? When you say that out loud today, it sounds obvious. Of course there are underground railways. Most major cities have them. But in the 1850s, this wasn't obvious at all. This was genuinely shocking. Underground trains? How would that even work? Where would the air come from? Wouldn't people suffocate down there? How would you even get down to the platforms? How would you build something like that without the entire city collapsing into the tunnels? People literally thought Fowler was mad. Some of them said so publicly. The idea seemed impossible, dangerous, and probably impractical. But Fowler wasn't alone in thinking this way. By the 1850s, the idea of an underground railway was starting to shift in people's minds. It was still radical, but it was starting to feel less like pure fantasy and more like a genuine solution to a real problem. There were other engineers, other planners, other businessmen who were beginning to think that maybe, just maybe, you could put a railway underground. In 1854, the Metropolitan Railway Company was formed and received approval from Parliament to build an underground railway. This was huge. Getting parliamentary approval in Victorian Britain meant convincing a lot of sceptical people that your idea wasn't completely mad. But the Metropolitan Railway Company had backing, they had vision, they had engineers. What they didn't have at first was money and the actual ability to do it. For several years after 1854, nothing happened. Nothing at all. The approval existed. The plan existed. But construction didn't begin. Why? Money was extraordinarily hard to find. People were sceptical about whether this would actually work. Investors were nervous. The banks were nervous. Nobody wanted to put a massive amount of money into an unproven technology. What if it failed? What if nobody used it? What if there were catastrophic accidents and people died? The financial risk seemed enormous. But finally, after years of fundraising and planning, after dealing with skepticism and doubt, the Metropolitan Railway Company made it happen. On March 22, 1860, construction began. This was it. The moment everything changed. Not just for London, but for the world. What Fowler and his team were about to do had never been done before anywhere. They were going to literally tunnel beneath one of the world's greatest cities. Fowler and his team chose a method called cut and cover. It sounds simple in theory, and the basic concept actually was straightforward. But the execution was incredibly complex. Here's how it worked. They would dig trenches along the streets. These weren't small trenches. They were about 10 metres wide and 6 metres deep, big enough for a railway tunnel. Then they'd construct brick walls along the sides of these trenches. Railway tracks would be laid at the bottom. Finally, and this is the crucial part, they'd build a brick arch roof over the entire trench. Then they'd cover the whole thing back up with soil and street surface. The street would look almost normal again, except underneath. You'd have a working railway tunnel. The brilliance of this method was that it was actually feasible with 1860s technology. You didn't need super advanced equipment. You needed workers, picks and shovels, brick, mortar, and good engineering. It was physically demanding, but it was achievable. The downside was that it required you to completely tear up the streets, which meant dealing with all the existing infrastructure already underground. You couldn't just start digging without hitting things. There were sewers down there, water pipes, utility lines, all sorts of existing infrastructure. Every section had to be carefully planned and coordinated with building owners and existing services. But here's what makes the reality of this construction absolutely remarkable. It was incredibly dangerous. These weren't controlled, safe conditions. This wasn't a modern construction site with safety regulations, protective equipment, and careful oversight. This was the 1860s. Workers were injured constantly. Tools fell. Sections of tunnel collapsed without warning. Workers died. There were accidents that killed multiple people at once. Sometimes tunnel sections failed, and they'd have to rebuild them. The whole project was a constant battle against danger and uncertainty, and the scale was staggering. To build this tunnel from Paddington to Farringdon, the first section, they had to move millions of tons of earth. Millions of tons. All of it by hand or with steam-powered equipment. Thousands of workers. The project employed enormous numbers of people for years. These were dangerous jobs. The work was hot in summer, freezing in winter. People were getting injured at what would be considered an extraordinary rate by today's standards. But they kept going. The cost was enormous. By 1862, when they finished, the entire project had cost about £1,300,000. To give you a sense of what that means, the average worker at the time earned about £1 a week. So this project cost the equivalent of what thousands of workers would earn over their entire lifetimes. It was an absolutely massive investment. For perspective, some businessmen and investors thought the entire project was a waste of money. They predicted it would fail. They predicted nobody would use it. But by the end of 1862, against all the odds, against the skepticism and doubt, against the constant accidents and near disasters, the tunnel was complete. The platforms were built. The tracks were laid. The infrastructure was ready. On January 10th, 1863, the first trains ran. The public had absolutely no idea what to expect. Underground trains, would they be safe? Could you actually breathe down there? Would it be terrifying? Would people use it? Nobody knew, but they were about to find out. What actually happened surprised everyone. On opening day, incredibly high numbers of people used the new service, much higher than anyone had predicted. The concept worked, the engineering worked, the technology functioned. People weren't afraid, they embraced it, they loved it, they used it to escape the gridlock above. Suddenly you could move across London quickly. Suddenly, thousands of people had access to fast transport. The Underground Railway was a success. But here's the part that truly stuns me when I think about it. Those original stations from 1863 are still operating today. I mean, the actual physical stations. Baker Street Station, which opened that first day on January 10th, 1863, still uses sections from that original construction. You can still walk on the same platforms where the very first London Underground passengers stood over 160 years ago. The platforms have been maintained, carefully preserved, restored at times, but they're fundamentally the same spaces. The brickwork is still there. The Victorian engineering is still there. You're standing on something that directly connects you to one of the most important engineering moments in human history. The station started small, just 2 platforms running roughly east to west beneath Marylebone Road. That's it. 2 platforms, simple infrastructure. But from that very first day, something special was happening underneath London's streets. Nobody knew it yet, but this little station would become the most connected hub in the entire London Underground. It would grow and expand and transform, becoming the central interchange that would serve 5 different tube lines and 10 platforms total. But that transformation hadn't happened yet. On January 10th, 1863, it was just the world's first underground station, and it was proving that a radical, seemingly impossible idea could actually work. Here's something that genuinely confuses most people, even people who have used the London Underground for years, people who work at Baker Street, people who commute through there daily, people who've been riding the tube their whole lives. They often don't fully grasp this. Baker Street Station isn't really one station. I mean, technically it's one station on the map. It has one name, it has one postal code, but physically it's actually 3 separate stations that were built at completely different times, in different places, with different architectural styles and construction methods. They're all stacked on top of each other, or more accurately below each other. They're physically separated. They operate somewhat independently, but they share the same name and location. Think of it like this. Imagine if you had 3 completely different buildings in the same spot, but they couldn't see each other. They're hidden from one another. They operate in their own spaces. They have their own entrances in some cases, but passengers can move between them using corridors and escalators. That's basically what Baker Street is. The first station is the original one from 1863. That's the Metropolitan Railway Station. It's the oldest section. 2 platforms side by side, simple design, practical construction. That original station is still there today, operating for the Circle Line and the Hammersmith and City Line. And here's the remarkable part. You can actually recognise it when you see it. It looks different from the newer sections. It has the original Victorian architecture. The tilework is from the 1860s. The materials are authentic. The styling is distinctly Victorian. It's preserved because it's historically important. The tiles have been carefully maintained. Some restoration work was done in the 1980s to bring it back to something closer to how it looked when it first opened. If you walk through those platforms, you're literally standing in the 1860s. But then something changed. 8 years after the original Metropolitan Railway opened in 1868, a completely new branch line was created. The Metropolitan and St John's Wood Railway opened, and they needed new platforms at Baker Street to serve this branch. But instead of just adding platforms to the existing station, they built a completely different station section. This new part was called Baker Street East, and it was located in a physically different part of the overall Baker Street complex. This was a separate tunnel, different platforms, different infrastructure. It served the branch line going northwest toward areas like Willesden, eventually extending to Harrow and beyond. Now you had a situation where Baker Street had 2 completely separate station sections. Each had their own trains, each had their own platforms, each operated with its own schedule and its own infrastructure. You could change between them, but you had to navigate corridors and passages. They weren't integrated. They were distinct operations that happened to be in the same general location. And then came 1906. That's when things got even more complicated. The Baker Street and Waterloo Railway, what we now call the Bakerloo Line, opened. But here's where it gets really interesting. The Bakerloo platforms weren't built at the same depth as the original platforms. They were built much deeper underground. These are deep-level tube platforms. You have to take escalators down to reach them. Lots of escalators. You descend much further than you would to reach the original Metropolitan platforms. The Bakerloo platforms are a completely different world. Different architectural style, different depth, different construction method, different everything. This wasn't just another platform added to the existing station. This was an entirely new station built beneath the first two. So by 1906, Baker Street had evolved into this extraordinarily complex structure. 3 separate station sections at 3 different depths underground. 3 different architectural periods represented in the same location. The 1863 sections with Victorian brickwork, the 1868 additions from the Metropolitan and St John's Wood Railway, the 1906 deep-level Bakerloo platforms, each one representing a different era of engineering knowledge and design thinking, but the expansion didn't stop there. More additions came. In 1979, the Jubilee line opened, and it added even more platforms at an even deeper level. Then the Circle Line platforms, the various configurations of the Metropolitan line platforms. Eventually, this one location accumulated 10 platforms total, serving 5 different tube lines, 10 platforms, more platforms than any other station on the entire London Underground network. The engineering problem this created was absolutely immense. How do you connect 3, 4, or 5 separate stations at different depths? How do you route thousands of passengers between these different sections safely and efficiently? You need tunnels connecting them. You need escalators. You need corridors. You need staircases and passages and connecting routes. But you can't just rip everything up and rebuild it. The original sections are still operating. People are still using them. So you have to build new connecting infrastructure while keeping the existing station running. Passengers have to keep flowing through. Trains have to keep running. You can't shut the whole thing down. The answer involved a complex, intricate network of tunnels, escalators, corridors, and connecting passages. Some of these passages are closed to the general public for much of the day. Some areas have unmarked doors. Some sections are literally hidden from casual observation. There are sections of the station that tourists never see. There are spaces that regular commuters pass through without even noticing, not realising what they're looking at. There are parts of Baker Street Station that exist but are barely known to exist by most people who use it. And here's where it gets really fascinating. Not all the original connecting infrastructure is still in use. Some passages have been sealed. Some tunnels that once connected different lines no longer carry passengers. Some platforms, originally built for one line, have been repurposed or are no longer connected to their original tunnels. The station is like an archaeological site with different layers. You could theoretically walk through it and experience 160 years of different engineering eras, different architectural styles, different construction methods, all compressed into one journey. Victorian brickwork exists right next to modern concrete. Original 1860s tile work is visible just meters away from 1980s refurbishment design. Escalators from the 1910s stand near escalators installed in the 1990s. This is one of the big reasons why the Hidden London tours focus so heavily on Baker Street. There's genuine underground history here. Hidden passages, closed corridors, abandoned sections, areas that were designed for one line but repurposed for another. Lift shafts that no longer lead anywhere. There are sections of tunnel that connect different lines, and these connections are rarely used, mostly just for maintenance trains. When you go on one of these tours, you get to see parts of the station that are completely closed to the public under normal circumstances. You get to see original Victorian brickwork. You can see exactly how the tunnel was constructed. You can trace the changes in construction methods as different eras of the station were built. The tiling throughout the station tells its own fascinating story. The oldest platforms, the 1863 sections, have specific Victorian-era tiling patterns. These weren't just random designs, they were carefully chosen, professionally installed. When the Bakerloo platforms were built in 1906, they used different tiles. You can see the shift in design aesthetic between 1863 and 1906. By the 1980s, when the Jubilee platforms were refurbished, they introduced yet another design philosophy. But here's the amazing part. They didn't completely replace all the old tiles. They kept many of the original tiles from 1979 and added new ones depicting Sherlock Holmes. So you have this mixed design on the Jubilee platforms, original design from when it opened, mixed with newer Sherlock Holmes silhouettes. It's both historically grounded and culturally aware. It somehow works. The escalators tell their own story too. The original Metropolitan platforms from 1863 don't have escalators. They have stairs, as they originally did, though modern moving walkways have been added over the decades. But the Bakerloo platforms have proper escalators. In fact, the first escalators ever installed on the London Underground were at Baker Street in 1914. Think about that. Escalators were revolutionary technology at the time. People were genuinely nervous about using moving stairs. You'd have guides standing there, instructors, people specifically trained to help passengers learn how to use escalators. Can you imagine being so unfamiliar with the technology that you needed an instructor to teach you how to step onto a moving staircase? Now escalators are everywhere, we barely notice them. But in 1914, they were cutting-edge technology. When you walk through different sections of Baker Street, you're literally moving through different historical periods. Each section represents what engineers thought was best practice at the time it was built. The materials reflect what was available and affordable at that moment. The design reflects what was considered modern and efficient. So Baker Street, in a sense, is a museum of underground railway design philosophy. It's a physical record of how engineering thinking evolved from 1863 to 1979 and beyond. The construction of Baker Street Station wasn't just an engineering project. It wasn't just about digging tunnels and laying tracks. It was fundamentally about disrupting an entire city. Urban disruption on a scale that's almost incomprehensible to us today. These were the 1860s. This was London, the centre of the British Empire, the wealthiest city on earth, absolutely packed with people, buildings, businesses, commerce happening constantly. And the Metropolitan Railway Company decided to dig it up. Picture this in your mind. Marylebone Road, one of London's important streets, not a minor street. This was a main thoroughfare. It had shops lining it, residences above those shops, businesses. The street was the lifeblood of commerce for an entire neighbourhood. Every day this street was bustling with activity. Delivery wagons came and went, pedestrians crowded the pavements, shoppers moved between stores. It was a living, functioning part of London's commercial infrastructure. And then one day in March 1860, construction begins. They start digging trenches straight down the middle of the street. Not small trenches, massive trenches, 10 metres wide, 6 metres deep. The entire street is being systematically opened up. Equipment arrives, steam-powered machinery, workers with picks and shovels. The noise would have been constant and deafening. The dust would have been overwhelming. The street that was once a functioning commercial thoroughfare becomes a construction site, a massive, chaotic construction site. For 3 years this goes on. Not 3 weeks, not 3 months, 3 years. For 36 months, Marylebone Road and Baker Street are essentially a construction zone. Sometimes the entire street is torn open, sometimes they're working on different sections. But for years, this main street is disrupted. The inconvenience must have been absolutely staggering. Imagine your favourite shopping street, the one you use regularly, being completely torn apart for 3 years. Imagine trying to run a business above or next to an active construction site for 3 years. The shopkeepers were furious. Shop owners couldn't get their deliveries properly. Their customers couldn't easily access their stores. The disruption was affecting their income. Their livelihoods were at risk. Residents in the buildings above the shops were furious. The noise, the dust, the constant vibration. Imagine trying to live above a construction site. Just try to imagine that. For 3 years. No wonder people were angry. The anger was justified. The disruption was real and significant. But traffic above ground wasn't just disrupted because of the construction itself. It was disrupted because the street was now partially unusable. You couldn't just drive a carriage through the middle of Marylebone Road when there's a giant trench there. So traffic had to be rerouted. The congestion above ground, which was already a problem, actually got worse during construction. More congestion while they were building the thing designed to reduce congestion. There's an irony there. People were suffering through worse traffic conditions now in the hopes that, in a few years, traffic would be better. The cut-and-cover method sounds elegant in theory. You dig, you build, you cover it back up, simple. But the reality was absolutely brutal. It was brutal because of what was already underground. Before you can just start digging without hitting something, you have to understand what's already down there. Sewers, water pipes, gas pipes, utility lines, decades of infrastructure that's already underground. You can't just smash through this stuff. You have to carefully identify where everything is, plan around it, work with it, negotiate with various authorities who controlled these services. The sewers were a particular nightmare. London's sewer system was relatively new in the 1860s. After a massive cholera epidemic in the 1850s, the city had invested heavily in new sewer infrastructure. That sewer system was now underground, and the Metropolitan Railway had to work around it. You can't block a sewer. People need sewage removal, so the engineers had to route their tunnels to avoid the sewer system, or in some cases they had to work with the sewer authorities to create temporary bypasses while they did their work. Imagine the complexity of that coordination. The work itself was physically demanding in ways that are hard to convey. Thousands of workers with picks and shovels digging out millions of tons of earth. The calculation is staggering. Between Paddington and Farringdon, they had to remove something like 4 million cubic metres of soil and rock. 4 million. All of it by hand or with steam-powered equipment. That's an incomprehensible amount of earth. All of it had to be excavated, transported somewhere, disposed of. Where did it all go? Some of it was used to fill in other areas, some was dumped outside the city. But 4 million cubic metres is a massive volume. The steam-powered equipment was primitive by modern standards. Steam shovels, steam-powered winches for lifting, steam pumps for dealing with water that would seep into the excavations. These machines were loud, dangerous, unreliable. They broke down constantly. They needed repair. And there were no safety regulations as we know them. Workers were getting hurt constantly, horrifically hurt. Crushed hands from equipment, broken bones from falls, burns from steam and hot metal, collapses that could kill multiple people at once. The Metropolitan Railway Company did keep records of accidents, though the records were probably incomplete. But what we know is that the accident rate was staggering. Workers died. They died from accidents. They died from infections from injuries. They died from collapses and explosions and equipment failures. Sometimes you'd have multiple deaths at once. The project nearly ran out of money multiple times. For a while, there was genuine fear that the entire project might be abandoned. What if the company ran out of money halfway through? What if they just gave up? There would have been a half-completed tunnel under London, an incomplete railway, all that disruption, all those casualties, and nothing to show for it. But John Fowler and the Metropolitan Railway Company persisted. Despite the accidents, despite the money problems, despite the constant complaints from residents and businesses, they kept going. By 1862, after years of this brutal work, the tunnel sections were complete, the platforms were built, the tracks were laid, and on January 10th, 1863, the first trains ran. And here's the interesting part. The public response was overwhelmingly positive. People came, lots of people. On opening day, passenger numbers were far higher than even the most optimistic predictions. The thing worked. The engineering worked. The technology functioned. What's remarkable is what happened to the surface after the initial construction. Marylebone Road and Baker Street now look like normal streets. You'd never know there's a massive tunnel running beneath them. The buildings above the tunnel were carefully preserved or rebuilt to look as they did before. Some were damaged during construction and had to be rebuilt from scratch, but they were rebuilt to match the original style. The street frontage was restored. The Metropolitan Railway Company even developed some property above the station themselves. They built apartment buildings and commercial buildings above the tunnel. Chiltern Court would eventually be built there, a luxury apartment building that still stands today. These developments served multiple purposes. They provided revenue for the railway company. They also completed the restoration of the damaged area. They showed that the streets were whole again. This surface-level restoration is often overlooked in histories of the underground, but it was almost as important as the tunnel construction itself. The railway company needed to prove something. They needed to prove that underground railways didn't mean permanent surface destruction. They needed to show that the streets could be restored to normality, that business could resume, that life could go on above while trains ran below. If they'd left the area as a broken, damaged construction zone, future transport projects would have faced even more opposition. The success of the early restoration actually made it easier to get approval for future underground railway lines. When they proposed the District Line, when they proposed other extensions, they could point to Baker Street and say, "Look, we disrupted this area, we built our tunnel, and we restored the surface. The area is thriving again, life goes on." This precedent helped pave the way for the massive expansion of the London Underground that would happen over the next few decades. The workers themselves deserve more attention. Who were these people who were digging tunnels under London? They were mostly labourers, working-class men looking for any employment they could find. The pay was reasonable for the time, which is why men took these dangerous jobs. But the danger was constant. Daily danger. These weren't trained engineers. Most of these were common labourers. Navvies, they were called. Navigators. The term came from men who dug navigation canals. These navvies had a reputation for being tough, for being willing to do dangerous work, for working in difficult conditions. They lived in temporary camps near the construction sites. The living conditions were poor, overcrowded, unsanitary. Diseases spread easily through these camps. During construction of the Metropolitan Railway, cholera outbreaks happened among the workers. People died from disease as well as from accidents. The navvies would work 10, 12, sometimes 14 hours a day. In winter, when it was freezing and wet. In summer, when it was oppressively hot and humid down in the trenches. The physical toll on these men was enormous. The engineering challenges were unique because nothing like this had been attempted before. The engineers were inventing solutions as they went. How do you support a tunnel when you're digging beneath buildings? How deep do the foundations of the buildings above go? How close can you get? If you get too close, could the building collapse into the tunnel? The engineers had to hire architects to assess every building along the route. They had to understand the structural integrity of each building. They had to calculate how much the tunnel construction would affect the ground above. There was also the problem of water. London sits on clay and chalk and other geological layers. When you dig, you hit water. Groundwater is constantly trying to seep into your excavation. In modern tunnelling, you'd have sophisticated pumping systems. In the 1860s, they had steam pumps, multiple pumps running constantly. If the pumps failed, the tunnel would flood. There are stories of tunnels that flooded, of sections that had to be excavated and rebuilt. The constant battle against water infiltration was one of the biggest challenges. The coordination required was staggering. You had to coordinate with the gas company about their lines. You had to coordinate with the water authority. You had to coordinate with the sewer authority. You had to communicate with building owners. You had to obtain permission from the church if your tunnel went beneath church property. There were endless bureaucratic hurdles. Letters were written, meetings were held, negotiations happened. The legal paperwork for this project was probably enormous. And then there was the problem of noise and vibration affecting surrounding buildings. Imagine your building starts vibrating constantly because of construction a few feet away. Plaster cracks, windows rattle, pictures fall off walls. It's maddening. People complained. They threatened lawsuits. They demanded compensation. The railway company had to deal with all of this while trying to keep the project moving forward. By the time the tunnel was completed in late 1862, the entire area had been transformed and then restored. It was a monumental feat of coordination and engineering. The final cost, £1,300,000, was vast, enormous, but it was done. The tunnel existed. It was real. And when trains started running on January 10th, 1863, it proved that the entire painful, chaotic process had been worth it. What most people don't know about Baker Street Station is that significant parts of it are closed to the public. I'm not talking about staff areas or technical rooms. I'm talking about actual station infrastructure. Entire sections have been sealed off or restricted. There are platforms that were built but are no longer in regular use. There are passages that connect different lines but are rarely, if ever, traversed by passengers. There are lift shafts that serve absolutely no purpose anymore. There are corridors that lead nowhere. Some of these spaces are locked behind unmarked doors. Some are just forgotten. It's not a conspiracy or anything sinister. It's just the natural result of nearly 160 years of infrastructure changes, reroutes, line changes, and evolving needs. When the Bakerloo line was built in 1906, they created 4 platforms to serve that deep-level tube line. Platforms 8 and 9 were the main operational platforms. But as the network evolved over the decades, as lines were redrawn and reconfigured, as new lines opened and took over certain services, some of those original connections became redundant. They were built for a purpose, but that purpose changed. The infrastructure remained, but it wasn't needed anymore. For example, there's a connecting tunnel between the Bakerloo line northbound platform and the Jubilee line northbound platform. This tunnel physically exists. It's real. It's there underneath Baker Street. But regular passengers never use it. It's not a passenger route. It's used only for what are called engineering trains. Special trains that are used to move other trains, to transfer rolling stock, to do maintenance and repairs. So this tunnel, this expensive piece of infrastructure that was built decades ago, functions now only for occasional maintenance purposes. It's like a hidden artery in the station's circulatory system. Similarly, when the Jubilee line opened in 1979, it was originally supposed to be called the Fleet Line. The proposed route was different than what was eventually built. Some of the original planned infrastructure for that alternative route was actually constructed. So there are sections of Baker Street Station that were built with the intention of serving trains that never came, tunnels that were dug in anticipation of services that never materialized. They exist. They're just sitting there, not used, not needed, but they're there. The deep platforms, the Bakerloo and Jubilee platforms, have areas that are simply closed. If you walk through those platforms, you'll notice unmarked doors. Regular passengers probably walk past them without even thinking about them. But these doors lead to restricted areas. Some of them are storage rooms. Some are emergency equipment areas. Some are just sealed off sections from previous eras of the station's history. What's behind them? Office space, old equipment, materials, utilities. Sometimes just empty space that's been cordoned off. These closed sections represent the history of the station. They're physical remnants of configurations that no longer exist. London Transport Museum runs special hidden London tours specifically to explore these closed areas of Baker Street. These tours take people through sections of the station that don't normally get open to the general public. You get access to places that regular commuters will never see. What you discover is genuinely fascinating. You see original Victorian brickwork from the 1860s. You see changes in construction methods as different sections of the station were built over different decades. You see the evolution of engineering thinking. You see how the tunnel was originally constructed, the hand-placed bricks, the mortar, the arch construction. It's all visible if you go into these restricted areas. One particular point of fascination is something called ghost platforms. These exist at various places on the London Underground. They're platforms that were built, sometimes used for a time and then abandoned. They're closed to the public, but they're still physically there. Baker Street doesn't have obvious abandoned platforms like some other underground stations do, but it does have old platform sections that have been incorporated into the modern infrastructure. There are spaces where platforms used to exist that are now part of corridors or storage areas. You wouldn't recognise them as former platforms unless someone pointed it out and explained the history. But they're there. The tiling and tilework throughout the station tells a comprehensive story if you know how to read it. The oldest platforms, the 1863 sections, have specific Victorian-era tiling patterns. These weren't just functional tiles, they were designed. They were chosen for their appearance as well as their practicality. The colour palette is distinctly Victorian. The patterns reflect the design sensibilities of the 1860s. When the Bakerloo platforms were built in 1906, they used different tiles. You can see the aesthetic shift between 1863 and 1906 in the actual tiles on the walls. By the time the Jubilee platforms were built in 1979, design preferences had shifted again. The tiles are different, the colour schemes are different, the overall aesthetic is modern compared to what came before. But here's the amazing part about the Jubilee platforms. In the 1980s, when they were refurbished, they didn't completely replace all the old tiles. They kept many of the original tiles from 1979 and added new ones depicting Sherlock Holmes. So you have this mixed design on the Jubilee platforms. Original design from when it opened in 1979, mixed with newer Sherlock Holmes silhouettes added in the 1980s. It's both historically grounded and culturally aware. The designers could have just replaced everything with new tiles, but they chose to preserve some of the original design while adding the new cultural reference. It somehow works aesthetically. It's a nice balance between history and contemporary culture. The escalators tell their own fascinating story about technological evolution. The original Metropolitan platforms from 1863 don't have escalators. They have stairs, as they originally did. Though modern moving walkways have been added over many decades, but the Bakerloo platforms have proper escalators. In fact, and this is genuinely remarkable, the very first escalators ever installed on the London Underground were at Baker Street in 1914. That's only 51 years after the Metropolitan Railway opened, but it felt like a leap forward in time. Escalators were revolutionary technology. People were genuinely nervous about using moving stairs. You have to remember, most people in 1914 had limited experience with mechanical devices. An escalator was mysterious. It was moving. It was going to move you automatically. What if you fell? What if your clothing got caught? What if it suddenly stopped? There were legitimate concerns. To help people feel comfortable, London Transport actually stationed guides on the escalators. Trained staff members would stand there and help people learn how to use them. Step on here. Hold the handrail. Yes, it will move you up. Don't be frightened. Can you imagine needing an instructor to teach you how to use an escalator? But that was the reality in 1914. The technology was so new and unfamiliar that people needed guidance. When you go on a hidden London tour and you get to see the original tunnel construction up close, it's striking. You can see the exact methods used, the brickwork from 1860 to 1862. You can see how they built the arches, you can see how they fitted brick against brick, you can see how they managed drainage and ventilation. The craftsmanship is evident. Every single brick was placed by hand. There was no machinery doing this, just workers, tools, skill and engineering knowledge. The tunnel is remarkably well preserved in many sections because it's been underground for over 160 years. It's not exposed to weather, it's not exposed to air pollution, it's not exposed to the elements. The underground environment has actually preserved it. There's also ongoing mystery surrounding the station's structural stability and condition. Over 160 years, the ground has shifted. The brick and stone have weathered. Water has seeped in places despite efforts to prevent it. The tunnels require constant maintenance. Sometimes you hear about track faults at Baker Street. There was a notable issue in 2025 where cracks were discovered in the track junction. This wasn't a small problem. It required extended maintenance work. The Metropolitan line had to be suspended between Baker Street and Aldgate for weeks, while engineers fixed the cracked pointwork. This is the reality of maintaining ageing infrastructure. The Victorian brickwork can only take so much punishment from modern high-frequency trains. Trains running constantly year after year create vibration. Vibration causes stress on the structure. Eventually cracks appear. Maintenance is required. The deepest sections of Baker Street actually go beyond where most people walk. There are sub-basement levels. spaces used for equipment, utilities, storage, maintenance access. These are completely closed to the public under normal circumstances. There are no passenger areas down there. It's purely functional infrastructure. During tours, you get hints of this deeper infrastructure. You realise the station isn't just what you see as a passenger. It's a much more complex three-dimensional structure with layers and levels and hidden spaces. It's like an iceberg. What you see above the waterline, the platforms where you stand, the corridors you walk through, is just the visible part. Below that, there's enormous complexity. When you actually walk through Baker Street on a regular day as a commuter, you're experiencing maybe 30% of what's actually there. You use certain corridors, you use certain escalators, you get from point A to point B efficiently. But entire sections of the station are invisible to you. They exist, but they're not part of your passenger experience. This separation between the public spaces and the closed spaces creates a kind of secret architecture, a hidden layer to the station. The escalators deserve more attention because they represent technology adoption at a crucial moment. When those first escalators were installed at Baker Street in 1914, it was genuinely cutting edge. The technology had only been invented a few decades earlier. It was American technology being introduced to London. The London Underground saw the potential. Moving stairs could move people more efficiently than stationary stairs. They could handle higher volumes. But people needed to trust them first. The guides who stood on those early escalators weren't just there for decoration. They had real jobs. They helped people who were nervous. They watched for safety hazards. They made sure people understood how to use the technology. As people became more comfortable with escalators, the need for guides diminished. But this training period was crucial. It made escalators normal. It made them accepted. By the 1920s and 1930s, escalators started appearing in other stations. By today, they're everywhere, and nobody thinks twice about them. The sealed sections of Baker Street raise interesting questions about what exactly is behind those doors. Some of them are storage for station equipment, spare parts for trains, maintenance materials, cleaning supplies. Some of them are spaces that were designed for one purpose that never materialized. Some are emergency exits or emergency equipment areas that need to remain accessible, but don't need to be part of the regular passenger flow. The maintenance challenges are substantial and ongoing. The 2025 track fault that required weeks of repair work is just one example. Imagine the complexity of maintaining infrastructure that's been in continuous use since 1863. The original platforms have been carrying trains for over 160 years. The wear and tear is real. The concrete and brick degrade. The steel rusts in places where water has gotten through. The track itself wears from constant use. Engineers are constantly monitoring, inspecting, assessing what needs repair. Some of this work is routine, some of it is emergency, but it never stops. The drainage systems are particularly interesting. Over 160 years, the water management systems have evolved. The original 1860s tunnel had basic drainage. As the station expanded and new sections were built, drainage systems were upgraded. But coordinating drainage across multiple tunnel levels, across sections built at different times with different systems, is complex. If one section's drainage fails, water can back up into other sections. This is why you sometimes see maintenance work happening that seems minor. They might be clearing a drain or replacing a section of drainage pipe. But these minor works are essential to keeping the entire system functioning. The architectural historian or engineer walking through Baker Street sees something that regular passengers don't. They see the fingerprints of different eras. They see how problems were solved in different ways at different times. They see redundancy built into the system. Some of this redundancy is no longer used, but it's still there. It represents a kind of archaeological record of the station's evolution. The Hidden London tours have become popular specifically because they reveal these hidden aspects. Tourists pay to go on these tours because they're curious. They want to see what's behind those unmarked doors. They want to understand how the station actually works. They want to connect with the history in a visceral way. Walking through the same tunnels, touching the same Victorian brick, standing in spaces that haven't changed much in over 100 years, it's a powerful experience. It makes the history real in a way that reading about it never could. From 1863, when the Metropolitan Railway opened, until the 1930s, the London Underground grew in a somewhat haphazard way. It wasn't planned as a coherent system. Different companies owned different lines. There was the Metropolitan Railway, which originally ran from Paddington to Farringdon. There was the District Railway, which served different areas. There was the Baker Street and Waterloo Railway, which opened in 1906. There were other smaller lines. These weren't all part of one unified company. They were separate companies competing for passengers, sometimes cooperating, sometimes working against each other. They didn't always cooperate. Sometimes they operated on shared tracks, which caused friction. Sometimes they didn't. It was a confusing mess that created inefficiencies and operational nightmares. Baker Street was where many of these lines converged, which made it a crucial but also a deeply problematic junction. The original plan for what we now call the Circle Line was elegant in concept. The vision was simple: create a complete circle connecting all the major routes. A loop around central London that would tie everything together. In theory, this was brilliant. In practice, it was a disaster. The reality of shared track operations meant constant conflicts. Trains were constantly delayed because they were all trying to use the same rails. If a Metropolitan Railway train had priority, it could block a District Railway train. If a Circle Line train had priority, it could delay the Bakerloo. It was like a traffic jam, but underground and with trains instead of carriages. The Metropolitan Line, which served the northwestern suburbs like Harrow, Wembley and beyond, kept getting backed up at Baker Street. This was because it had to share tracks with the Circle Line and other services. There were only so many trains that could fit through Baker Street at any given time. The bottleneck was real and severe. By the 1930s, this congestion was becoming a genuine crisis. The underground system was literally reaching capacity at certain critical points. You couldn't just add more trains because the tracks couldn't handle them. You couldn't run trains more frequently because there was nowhere to put them. The system was constrained. Something had to change. Enter Charles Tyson Yerkes. He was a controversial American financier and businessman. Born in Philadelphia, Yerkes had made his fortune in American railways and street railways. He was wealthy, ambitious, and willing to invest money in transport infrastructure when few others would. He had a vision. He saw the potential in the London Underground, but he also saw the problems. The system was fragmented. It was inefficient. It was operated by multiple competing companies. Yerkes believed that what London needed was better organisation and substantial capital investment. He believed that if you unified the various transport companies and invested properly, you could transform London's transport system. Yerkes was a flamboyant character. He built himself a magnificent mansion in London. He collected art. He was high profile and somewhat controversial, but he put his money where his mouth was. He invested heavily in London's transport. He pushed for the unification of all the separate transport companies. This wasn't an easy process. There was resistance. Different company owners didn't want to give up their independence. There were complicated negotiations. There were legal battles. But eventually it happened. On July 1st, 1933, the London Passenger Transport Board was formed, bringing everything under one unified authority. The LPTB, as it was called, took over the Metropolitan Railway, the District Railway, the Bakerloo, and numerous other lines and services. Suddenly, instead of competing companies operating independently, you had one organisation running all of London's transport. This unified control meant you could finally solve operational problems that had plagued the system for decades. You could replan routes. You could reassign services. You could build new infrastructure that made sense from a system-wide perspective, rather than from an individual company's perspective. One of the first major projects the LPTB undertook was addressing the Baker Street bottleneck. The Metropolitan line had 2 tracks running through Finchley Road to Baker Street, but 4 tracks needed to merge into those 2. 4 tracks carrying trains from 4 different routes, all trying to funnel into 2 tracks. It was impossible. Something had to give. The solution the LPTB developed was elegant. Build a branch tunnel from Baker Street northward that would serve as an alternate route. This branch would take over some of the services that were currently using the main Metropolitan line tracks. This became the Bakerloo line service to Stanmore. It wasn't a new line exactly. It was a rerouting of existing services onto existing infrastructure, with new tunnels connecting Baker Street to that infrastructure. Construction began in April 1936. This was an enormous undertaking. They had to build new tunnels from Baker Street northward while the station was still operating. You couldn't shut down Baker Street. Thousands of people used it every day. Trains had to keep running, so the engineers had to work around operating trains. They had to carefully coordinate so that construction didn't interfere with passenger service. They had to create new platforms at Baker Street for the Bakerloo line to serve these services. They had to ensure that the existing Metropolitan line platforms could be modified to work with the new layout. The construction took years. This wasn't quick work. You can't just dig tunnels under London quickly. You have to be careful. You have to avoid existing infrastructure. You have to do the work in sections to avoid disruption. You have to deal with geological challenges. By November 1939, the new arrangement was finally complete and ready for operation. On November 20th, 1939, the new service pattern opened. The Bakerloo line took over the Metropolitan line suburban services north of Baker Street. The Metropolitan line was freed up to carry long-distance services to outer suburban areas. This immediately improved efficiency. Trains were no longer piling up at Baker Street trying to get onto the same 2 tracks. The bottleneck was solved. What's remarkable about this is that it's a perfect example of engineering solving a complex logistical problem through infrastructure innovation. Instead of just accepting congestion, the engineers identified the problem, understood its root cause, and designed a solution. The solution wasn't simple, but it worked. It cost money. It required years of construction, but it fundamentally improved the functioning of the system. But the story doesn't end there. The universe has a way of creating new problems when you solve old ones. In the 1970s, a new problem emerged. Now the Bakerloo line itself was becoming congested. Too many branches using the same tracks through Baker Street. The branch to Stanmore was being served by the main Bakerloo line tracks. The main Bakerloo service was running through the same tracks. Capacity was being reached again. History was repeating itself. You couldn't solve the problem the same way twice. You needed a different solution. The solution was the Jubilee line. This line had been announced in the 1960s, but it took years to plan and get approved. It was initially called the Fleet Line, and the proposed route was different than what eventually got built. The Fleet Line was supposed to go from Baker Street in different directions, but after years of debate and planning, the route was changed, and it became the Jubilee Line. The Jubilee was designed to take over the Bakerloo Stanmore branch, providing a relief service. This would free up Bakerloo capacity for other services, and also provide a new north-south connection through central London. The Jubilee Line's construction was unprecedented in complexity. They had to bore new tunnels beneath existing infrastructure. They had to design it to work with Baker Street's already complex layout. Remember, Baker Street already had 3 separate station sections at different depths. Adding a 4th was complicated. They had to ensure that the Jubilee Line platforms could connect with the other platforms. They had to ensure it could eventually extend beyond what was initially planned. Eventually, the Jubilee Line would extend all the way to Stratford in East London and beyond, but initially, it was just going to take over the Stanmore branch. On May 1st, 1979, the Jubilee Line opened. The first section was between Charing Cross and Embankment. Then it extended to Baker Street, taking over the Bakerloo Stanmore branch. The new platforms at Baker Street were built at the deepest level. This is when Baker Street became truly unique. Now it had platforms for 5 different lines, arranged at 2 different depths, serving 10 total platforms. It was the most complex interchange on the entire London Underground, and even with the new Jubilee Line relieving pressure, Baker Street was still operating at high capacity. What's remarkable about this history is how it demonstrates engineering solutions to real-world problems over decades. Each time they encountered a bottleneck, they didn't just accept it, they solved it. Sometimes the solution took years, sometimes it required massive capital investment, sometimes it meant building entirely new tunnels through central London. But the solutions worked. They adapted the infrastructure to meet changing demands. They kept the system functioning. The Baker Street bottleneck is actually used as a case study in engineering schools and transport planning courses. It's an example of how infrastructure can become constrained when demand exceeds capacity. It's an example of how you identify problems and develop solutions. It's also an example of the limitations of incremental development. If the entire London Underground had been planned from the beginning with full knowledge of future demand, it might have been designed differently. But that wasn't possible. They couldn't have predicted the future. They built what made sense at the time. Then, as demand grew and circumstances changed, they reacted to real problems with real solutions. Each solution built on previous infrastructure. Each adaptation made the system better without requiring a complete redesign. Charles Tyson Yerkes deserves more detailed attention because he was a genuinely important figure in London's transport history, though he's often overlooked. He came to London in the 1890s with a reputation. In America, he'd been involved in street railway operations in Chicago and Philadelphia. He'd made money. But he'd also been controversial. There were accusations of financial impropriety. Some people thought he was a visionary. Others thought he was a scoundrel. He was probably both. He was definitely ambitious. What Yerkes did that mattered was invest money. He believed in London's transport future. He invested in the Baker Street and Waterloo Railway, which became the Bakerloo. He backed projects. He spent millions of pounds on transport infrastructure. He died in 1905, before the Bakerloo even opened, but his legacy was substantial. He proved that you could make money investing in London transport. He showed that capital was available if you had a vision. His impact on London's underground development was significant, even though people don't remember his name today. The formation of the London Passenger Transport Board in 1933 was genuinely revolutionary from an organisational standpoint. Imagine trying to unify competing companies. Each one had its own staff, its own traditions, its own way of doing things, its own unions with their own agreements, its own financial structure. Bringing all of this under one unified authority meant reconciling these different systems. It meant redundant positions being eliminated. It meant some people keeping their jobs and others losing them. It was a massive organisational undertaking. But the benefit was that now one person could look at the entire system and make decisions based on what was best for the overall network, not what was best for an individual company. The LPTB hired a new chief, named Frank Pick. Pick was a visionary. He believed that the underground should be a coherent system with consistent design, consistent branding, and coordinated operations. He oversaw design standards. He pushed for the famous London Underground map design, created by Harry Beck, which simplified the actual geography for clarity. He believed that transport infrastructure should be beautiful as well as functional. This design philosophy influenced the entire system. The construction of the Bakerloo extension to Stanmore during 1936 to 1939 happened during an interesting historical moment. This was the late 1930s. World War II hadn't started yet, but tensions were rising. The Spanish Civil War was happening. People were worried about the future, but construction in London continued. The engineers and workers kept building. They were creating infrastructure for a future that would turn out to be very different from what anyone anticipated. Some of the tunnels built during this period would eventually be used as air raid shelters during the Blitz in 1940 to 1941. The deep underground platforms would protect thousands of Londoners from German bombs. Infrastructure built for one purpose ended up serving a completely different purpose just a few years later. The engineering challenges of this construction period were substantial. The engineers had to bore tunnels through London's geology without disturbing the surface. They had to avoid existing sewers, water pipes and utility lines. They had to work around buildings. They had to deal with groundwater. They had to create connections between the new tunnels and the existing infrastructure at Baker Street. All of this while passenger trains were still running. Modern tunnelling using tunnel boring machines wasn't available. They used traditional methods: explosives to break rock, picks and shovels to remove material, support structures to keep tunnels from collapsing. The stations built during this period, like St John's Wood and Swiss Cottage on the Bakerloo line, reflected the design standards of the 1930s. They were modern, efficient, well lit. The platforms were spacious. The architectural style was clearly 20th century. But they built on the principle established by earlier generations: create good, functional stations that would serve the public well for decades to come. The impact of solving the Baker Street bottleneck was substantial. Trains that had been consistently delayed now ran on schedule. Passengers experienced shorter journey times. The reliability of the system improved. This reliability mattered because it encouraged people to use the underground more. As ridership increased, the system justified further investment. Infrastructure improvements attracted more passengers, which generated more revenue, which allowed for more improvements. A positive cycle was created. The Jubilee line, when it finally opened in 1979, represented the culmination of decades of planning and work. By then, the world had changed dramatically since the 1930s. The technology was different. The design standards had evolved. But the fundamental principle was the same: solve the bottleneck by creating alternative routes and distributing passenger load across multiple services. The Jubilee line successfully relieved pressure on the Bakerloo line and also provided new north-south connectivity through central London. Here's an interesting quirk of history, and it's the kind of thing that shows how popular culture and real places can become tangled together in unexpected ways. Baker Street Station is famous partly because of a fictional character who has never existed. Not even for a single moment. He was invented, made up, created from imagination. Yet this character became so culturally powerful that he shaped how people think about an actual real location. The character is Sherlock Holmes, the detective. He was created by Sir Arthur Conan Doyle, a Scottish writer in the 1880s. Doyle wrote stories featuring this brilliant, eccentric detective who solved impossible crimes using logic and observation. The stories were wildly popular. People loved Sherlock Holmes. They were obsessed with him. They treated him like he was real. Readers would write letters to the address where Sherlock supposedly lived, asking for help with their problems. Some people genuinely believed he existed. That address was 221B Baker Street. When Doyle was writing the stories, he needed an address for his character. He needed something that sounded real. He needed somewhere in London that readers would recognise or could imagine easily. He chose Baker Street. Why? Partly because it was already becoming a significant street. The underground station had opened in 1863, just 2 decades before Doyle was writing. The street itself was well known. It was a good choice for a fictional address. Doyle wasn't deliberately trying to make Baker Street famous. He just picked an address that sounded appropriate. But that choice had consequences. For over a century, this didn't really influence the underground station itself. The station was just a station. It served the public. It moved people from place to place. The Sherlock Holmes connection was something that existed separately. People who read Sherlock Holmes stories might have thought of 221B Baker Street. But the underground station was its own thing. The connection wasn't really leveraged or acknowledged by Transport for London. It was just a coincidence that the world's first underground station happened to share a name with the home address of a fictional detective. But in the 1980s, that all changed. As part of a refurbishment programme for the Jubilee line platforms, London Transport Museum made a deliberate decision. they decided to incorporate Sherlock Holmes imagery into the station's design. It was an artistic and cultural choice. Why not acknowledge this famous association? Why not celebrate the connection between this historic station and this beloved fictional character? So they commissioned tile work, specially designed tiles featuring silhouettes of Sherlock Holmes, his distinctive profile, his deerstalker hat, his pipe. The design is subtle and elegant. It's not cartoonish or overdone. It's sophisticated. You might not notice it immediately when you first see it, but once you see it, it becomes obvious. The entire platform is decorated with these repeated Sherlock Holmes silhouettes and related scenes. There are scenes that reference famous Holmes stories. There's a sense of Victorian mystery and intrigue woven into the design. This decision transformed the station's cultural identity fundamentally. Suddenly, Baker Street Station wasn't just an important transit hub. It wasn't just the world's oldest surviving underground station. It wasn't just the station with the most platforms. It became a tourist destination. People came specifically to see the Sherlock Holmes tiles. The station became a must-visit location for fans of the character. Tourists from around the world started coming to Baker Street specifically to experience this. The Sherlock Holmes Museum is located right up the street at 221B Baker Street, about a 5-minute walk from the station, so the area became a sort of Sherlock Holmes tourist circuit. You could visit the museum, which recreates the Victorian rooms where Holmes supposedly worked. You could stand in the rooms where Watson supposedly lived. You could see the furniture, the artefacts, the details of Victorian London life. Then you could walk down to the station and see the Sherlock Holmes tiles. There's a statue of the character standing outside the station, pipe in hand, deerstalker hat on his head. People photograph it constantly. What's genuinely fascinating is how this fictional connection actually enhanced and deepened the real history of the station, rather than diminishing it. The station is now famous for two things simultaneously. First, it's the world's oldest surviving underground station. It's a piece of Victorian engineering history. It's where the first London Underground trains ran. It's 160 plus years of continuous operation. That's real. That's historically significant. Second, it's home to Sherlock Holmes imagery. It's a literary landmark in a sense. It's connected to one of the most beloved fictional characters in the English language. These two identities coexist. They reinforce each other. It's history and fiction merged together in the same physical space. The tiles have become iconic in their own right. They're photographed constantly. They've been featured in documentaries. They've been written about in books about the underground. People come to Baker Street specifically to see them. In some ways, the Sherlock Holmes tiles have become more famous than many other aspects of the station. A casual visitor might come to see the tiles and not realise they're standing in infrastructure from 1863. The tiles might lead them to discover the history, rather than the history leading them to the station. The Sherlock Holmes Museum is a genuine tourist enterprise. It's one of the most visited museums in London. Tour groups come through regularly. People queue up to see the recreated Victorian rooms. They climb the stairs to see where the detective supposedly worked. They stand at the windows and look out at Baker Street. From the museum, it's just a short walk to the station. So tourists often combine the two attractions. They visit the museum, they see the tile work at the station, they take photographs, they buy souvenirs. It's become a complete experience, a full tourist circuit. What's interesting is that this actually happened somewhat organically. There wasn't a grand master plan from the beginning. Nobody in 1863 was thinking about how Sherlock Holmes would someday make the station famous. Nobody in the 1980s was necessarily trying to turn the station into a tourist attraction. The museum was created by someone passionate about the character. The station's tile design was an artistic decision by Transport for London designers. But together, these separate choices created a cultural phenomenon. Baker Street became associated with a fictional character in a way that probably no other real transit station has experienced. This speaks to the power of popular culture in shaping how we experience real spaces. The station existed for over 100 years without being particularly famous for Sherlock Holmes. But the moment the tiling was installed, everything changed. Suddenly, the cultural narrative shifted. Now, whenever people visited, they were experiencing the station through the lens of a detective who never existed. The tiles created a framework for how people understood and experienced the place. There's also a layer of British cultural pride here that's worth acknowledging. Sherlock Holmes is quintessentially British. He represents British detective fiction, British cleverness, British eccentricity and individuality, British justice tempered with pragmatism. Having his image cover a station at one of the world's oldest underground sites creates a particular narrative. It's a narrative of British innovation, British cultural achievement, British literary excellence. It's not subtle propaganda, but it's definitely part of the experience. When people visit this station, they're experiencing a piece of British cultural identity. The tiles have held up remarkably well over the decades. They were installed in the 1980s, so they're not ancient artifacts. They're relatively recent. But they're maintaining the aesthetic. The colours haven't faded significantly. The designs are still clear and visible. When the station undergoes refurbishment or maintenance work, the Sherlock Holmes tiles are preserved. They've become a protected part of the station's identity. They're not just decoration, they're integral to how the station is understood and experienced. New generations of visitors see these tiles without knowing they were added relatively recently. They might assume they're original. They might think they were always part of the 1979 Jubilee line design. They might assume they date back to some earlier era. But they were added about 40 years ago by people who recognised an opportunity to connect a real place to a beloved fictional tradition. It's a modest intervention, but it fundamentally changed how people experience the station. Baker Street Station exists within a remarkable neighbourhood. The street above contains histories within histories. If you go up to street level and look around, you're standing in a place that has layers of history stretching back centuries. The Portman Estate, which includes Baker Street, dates all the way back to the 16th century when Sir William Portman acquired the land. That's the 1500s. That's over 500 years ago. For hundreds of years after that, the land remained relatively undeveloped. It was countryside on the edge of London, open fields, agricultural land, a completely different landscape from what exists today. But then London started expanding. The city grew outward from its medieval centre. In the 18th century, as London's population increased and the city needed more space for residential and commercial development, things changed. In the 1750s, a man named William Baker, a gentleman of Marylebone, as he's described in historical records, leased some land from the Portman Estate and created a street plan. He laid out streets. He created a grid of properties that could be developed. One of these streets was named after him. That's where the name Baker Street comes from. It's not named after a profession or a place. It's named after a specific person from the 1700s who created a street plan. Throughout the 19th century, Baker Street transformed completely. In the early 1800s, it was residential. Wealthy people lived here. It was a desirable neighbourhood. But gradually it became more commercial. Shops opened. Businesses moved in. By the time the Metropolitan Railway came in the 1860s, Baker Street was already one of London's important thoroughfares. It had commercial value. It had foot traffic. It had established businesses. The arrival of the underground station accelerated this transformation dramatically. Suddenly thousands of people were using the station every day. That created demand. Demand for shops, demand for restaurants, demand for services. The street became even more commercial. More shops opened, more businesses. It evolved from a mixed residential commercial street into a primarily commercial street. Today, Baker Street is lined with shops, restaurants, offices and businesses. It's a retail destination as well as a transport hub. The building above the original Bakerloo station entrance, the one designed by Leslie Green in the Edwardian style, became iconic in its own right. Green was a designer known for his distinctive Art Nouveau-influenced tube station buildings. He designed many underground stations in the early 20th century. They have a particular aesthetic. They're green. They use distinctive glazed tiles. The Baker Street building is one of Green's most famous designs. It's Grade 2 listed, which means it's historically protected. You can't just modify it however you want. It has to be preserved. Above Green's building, the Metropolitan Railway Company built Chiltern Court, a luxury apartment building completed in 1929. It's a beautiful building, 8 stories tall, Edwardian architecture. It's Grade 2 listed as well, which means the entire building is historically protected. It's still in use today as residential apartments. Someone living in Chiltern Court is living in a building that's almost 100 years old, sitting directly above the station, above the Victorian tunnel infrastructure, above trains running on tracks that have been in use for over 160 years. The ground floor of Chiltern Court originally housed the Chiltern Court Restaurant, an elaborately decorated restaurant and tea room. It was a destination in itself. People would come specifically to eat there. It had ornate decoration. It had views of the street below. It was a place where you could enjoy a meal in style while being directly above one of the world's oldest underground stations. Later, it became the Metropolitan Bar, part of the Wetherspoons pub chain. It's still there today. The bar has exposed brick and period details. It occupies that unique space where the historical and contemporary merge, where commerce happens in spaces with historical significance. You can have a drink today above one of the world's oldest underground stations, literally standing above the Victorian tunnel infrastructure. You can look at the exposed brick and know that it's been there for over 100 years. The upper levels of Chiltern Court remain as apartments. They're expensive apartments, desirable apartments. People want to live there because of the location and because of the historic building. Living in Chiltern Court means living in a place with character and history. It means being connected to London's architectural heritage. The broader Baker Street area has connections to other significant London history. Lord's Cricket Ground is nearby. It's the home of English cricket, one of the world's most famous cricket venues. Regent's Park is close. It's one of London's major parks. Over 400 acres of green space in the middle of the city. You can walk from Baker Street Station and within a few minutes reach completely different London experiences. You can go from the busy transport hub to the shopping streets to the park to the cricket ground. The area is a strange mixture of commerce, culture, recreation, and history, all compressed into a relatively small geographic area. But there's also the reality of how Baker Street Station functions as a major transport interchange. The numbers are staggering. Over 22 million people pass through Baker Street annually. That's as of 2024 data. That's more than 60,000 people per day on average. And that's an average. During rush hours, the numbers are much higher. During off-peak hours, they're lower. But consistently, day after day, year after year, tens of thousands of people use this station. The station is designed to handle this volume, but it's clearly being used to near capacity. During morning and evening commute times, the platforms get crowded, the escalators have queues, the corridors are packed with people moving in different directions. It's a functioning system handling massive flows of human traffic. The station is clean and well maintained, but you can see the wear from constant use. All of this activity is happening above Victorian-era brick tunnels. Let me emphasise this because it's genuinely remarkable. The infrastructure that serves 22 million annual passengers is in many cases over 160 years old. The Metropolitan line platforms that opened in 1863 are still in daily use. They've been maintained and refurbished over the decades, but they're fundamentally the same spaces. The brickwork is still there, the basic structure is still there. This creates a strange juxtaposition. Ultra-modern transport demands, huge passenger volumes, frequent trains, high-speed operation, being served by heritage infrastructure, Victorian engineering carrying modern transport loads. This reality creates challenges. The station's importance means it's been a focus for accessibility improvements. The Victoria line had been completely automated, making it a model for disabled passenger access. But Baker Street's existing platforms made step-free access challenging. They're older, they're narrower in some places. They were designed for different traffic patterns. Modifying them while keeping them operating has been complex. There have been planned accessibility improvements over the years. In 2008, Transport for London proposed a project to provide step-free access to the subsurface platforms. It would have involved building lifts and bridges and reconfiguring passenger flow. But the project faced challenges. Listed building status meant certain modifications required special permission. The cost was significant. The disruption during construction would have been substantial. Transport for London applied for planning permission in 2008, but the application was subsequently withdrawn. In 2009, due to budgetary constraints, the step-free scheme was deferred. It remains deferred today. It's a real-world example of how old infrastructure can become difficult to adapt to modern needs. The history of the immediate area around Baker Street reveals how urban development works. In medieval London, this area was literally outside the city. In the 17th and 18th centuries, as London expanded, this area became attractive for development. The Portman estate was systematically developed. Streets were planned, buildings were constructed. By the 19th century, it was a fully developed neighbourhood of London. Then the Underground arrived, and everything changed again. The shift from residential to commercial wasn't just about adding shops. It was about the fundamental character of the neighbourhood changing. Residential neighbourhoods have different rhythms than commercial neighbourhoods. Residents want quiet. They want stable communities. They want to know their neighbours. Commercial neighbourhoods have different priorities. They want foot traffic. They want visibility. They want change and novelty to attract customers. As Baker Street became more commercial, the character of the neighbourhood shifted accordingly. Many residents moved away. Businesses moved in. The street became busier, more commercial, more transient. Chiltern Court deserves more attention because it represents a specific model of urban development. The Metropolitan Railway Company, which owned the land above the station, realised they could generate additional revenue by developing that property. They built residential apartments above the station. This had multiple benefits. It generated revenue for the company. It completed the restoration of the area after the underground construction. It created housing in central London. It was an economically smart decision that also served public interests. The Chiltern Court restaurant that operated on the ground floor was remarkable for its time. In the 1920s, you could come to Baker Street, go down to the platform, catch a train, go somewhere, and then come back and have a meal in an elaborately decorated restaurant directly above the station. It was futuristic. It was convenient. It represented the integration of modern transport infrastructure with modern urban amenities. The restaurant operated successfully for many decades before eventually becoming the Metropolitan Bar. Lord's Cricket Ground, just a short walk away, has its own long history. It's been the home of English cricket since 1814. It's one of the most famous sports venues in the world. The Marylebone Cricket Club, which owns Lord's, is one of the world's oldest sports organisations. The cricket ground has a specific cultural significance in British life. Test matches played there attract enormous crowds. International matches are played there. For many Londoners, Lord's is part of their cultural landscape in the same way the Underground is. Regent's Park is even closer to Baker Street than Lord's. It's a vast green space, over 400 acres, in the middle of central London. It was originally created as a royal hunting ground. Then it was incorporated into the city as a park. Today it's one of London's most important green spaces. There's a lake, there are gardens, there's open space for recreation. The park provides a crucial counterbalance to the urban density of the surrounding area. You can go from the crowded Baker Street station to the peaceful park within a 5-minute walk. It's a dramatic contrast. The reality of managing passenger flow at such a busy station involves constant attention. The station is cleaned regularly. Maintenance crews work during off-peak hours. The infrastructure is monitored. When there are technical issues, they're addressed as quickly as possible. The station operates with remarkable reliability considering its complexity and age. But there are constant challenges. The maintenance requirements never stop. The track fault that occurred in 2025, where cracks were discovered in the pointwork at Baker Street, required the Metropolitan line to be suspended for weeks. Pointwork is the system of tracks and switches that allows trains to change lines or direction. It's complex. It endures enormous stress from constant train traffic. Over time, cracks develop. They have to be repaired. But repairing them requires closing the line. During that closure, passengers were rerouted to other lines. The system adapted, as it always does when individual lines have problems. But it demonstrated the ongoing maintenance challenges. What makes Baker Street Station remarkable, when you step back and look at the bigger picture, is that it represents a specific moment in human history when something fundamentally impossible became possible. Before 1863, no one had successfully built an underground railway, not anywhere in the world. Think about that. The technology existed, the engineering knowledge existed, the mathematics existed, the materials existed, but nobody had actually done it. Nobody had successfully constructed a functioning underground railway, operated it safely, and moved passengers through it reliably. Baker Street Station was the proof of concept. It showed that you could dig beneath a city without destroying it. You could build complex infrastructure underground and have it function reliably. You could move thousands of people safely. You could do this in a dense urban environment while keeping surface life going. Every underground railway in the world that came after London has, in some way, learned from what was done at Baker Street. The solutions that Fowler and his engineers discovered were foundational. They established practices and principles that became standard. Think about modern cities. Paris has the metro, which opened in 1900. Berlin has the U-Bahn. Moscow has its famous metro system. Tokyo has the Tokyo Metro. Shanghai has its rapid transit system. New York has the subway. All of these systems exist because London proved it could be done. Yes, they refined the technology. Yes, they improved on it. They learned from London's experiences. They avoided problems that London encountered. But the fundamental concept came from Baker Street and the Metropolitan Railway. London was the pioneer. Every system that came after benefited from that pioneering work. The engineering innovation that cut and cover construction represented was crucial. It solved the problem of building shallow tunnels without requiring completely new land or new construction zones. Later, when they needed to go deeper, and they did need to go deeper as the network expanded, they developed deep-level boring technology. The Bakerloo platforms from 1906 used deep-level boring. But the shallow tunnels came first. Cut and cover made them feasible. It made it possible to build the initial network quickly enough and affordably enough that it could actually be implemented. If every tunnel required the deep-level boring technology that wasn't fully developed until later, the entire project might have been impossible. The station also represents a transition in how people thought about cities. It represents the transition from Victorian engineering to modern urban planning. The Victorians understood infrastructure. They understood scale. They understood project management. They built railways, bridges, aqueducts, sewers. They understood how to move massive amounts of material, how to coordinate large numbers of workers, how to plan complex projects. Baker Street Station is a product of that Victorian engineering confidence. It's built solidly. It's designed to last. It's constructed with quality materials and skilled labour. You can see it in the brickwork. You can feel it in the structure. The craftsmanship is evident. The care is evident. But beyond the physical infrastructure, Baker Street Station represents a shift in how cities were conceived. The Victorians began to see cities not just as collections of streets and buildings, but as systems of transport, systems of utilities, systems of commerce, systems of communication. Baker Street Station is part of that systems thinking. It's not just a building. It's not just a tunnel. It's a node in a network. It's designed to facilitate flow and movement within a larger urban organism. The station is part of a system that moves people across the city. The system is only as good as its weakest point. So each station had to be well designed. Each connection had to be efficient. Each platform had to handle its share of traffic. The various upgrades and modifications over 160 plus years show how infrastructure has to evolve. From 1863 to 1906, nothing much changed at the original platforms. They operated as they were designed to operate. But then the Bakerloo came and that forced a rethinking of the entire configuration. Then the Circle line changes in the early 20th century. Then the Jubilee line in 1979. Each time, the station had to adapt. Each adaptation built on previous infrastructure. Sometimes reusing it, sometimes replacing it, sometimes creating entirely new sections. The station evolved because the city evolved. Demand changed, population patterns changed, routes changed. The station adapted to meet these changing circumstances. This iterative development is actually a model for good infrastructure development. You build something, you see how it's used, you identify problems, you solve them. You build what's needed now and leave room for adaptation. You don't try to predict 160 years of future demands, which would be impossible anyway. Nobody in 1863 could have predicted what London would be like in 2025. They couldn't have predicted the population changes. They couldn't have predicted the development patterns. They couldn't have predicted social changes, economic changes, technological changes. So they did the right thing. They built what was needed then as well as they could, and they left room for future development. And for 160 plus years, the station has been modified and adapted to meet changing needs. The station has also become a symbol of London's status as a global city. When visitors come to London, many of them visit Baker Street Station specifically because it's famous. It's on the itinerary. They want to see the world's oldest underground station. They want to see the Sherlock Holmes tiles. They want to experience a piece of Victorian engineering history. The station has become a tourist attraction beyond its utility as a transit hub. It's famous. It's significant. It matters culturally. For Londoners who use it daily, it's probably less romantic. For them, it's a place to catch a train. It's often crowded. The escalators have queues during rush hour. It's where you might wait for a delayed train. It's a practical space. It's where you buy a coffee from one of the vendors. It's where you check which platform your train is on. It's part of your daily routine. But even for regular users, there's probably a moment at some point where you notice something. Maybe the original tile work on the old platforms. Maybe you notice something about the architecture. Maybe you see a plaque about the 1863 opening. Maybe you just pause for a second and realize that you're standing on infrastructure built almost 160 years ago. And you realize you're in a historically significant place. You're using something that your great-grandparents might have used. You're participating in a continuous story that stretches back to the Victorian era. The future of Baker Street Station is interesting to consider. The infrastructure is being well maintained. Plans continue for various accessibility improvements, though some of these have faced challenges due to the historic nature of the building. New trains are constantly being designed for the various lines. The Circle and Hammersmith and City lines have received new S-Stock trains. The Metropolitan line has been receiving new trains. The Bakerloo and Jubilee lines will eventually receive newer trains. But the fundamental configuration, the 10 platforms, the 5 lines, the 3-level structure, is probably set for the foreseeable future. Further major changes would be extraordinarily expensive and disruptive. What's clear is that Baker Street Station will continue to be important. London continues to grow. Transport demand continues to increase. The station is already at high capacity during rush hours. But it's proven over 160 years that it can handle growth and change. It's adapted before. It will adapt again. The principles that guided its construction, solid engineering, quality materials, thoughtful design, room for future adaptation, remain sound. The station works because those principles were applied well,